Thank you. I want to make 2 points in the 10 minutes that I've been given. The first is I want to talk about the rise in food prices and what the effect of that is on micronutrient malnutrition. And then the second, I'll have the last 5 minutes to talk a bit about the progress that we've made with biofortification. So as we speak, a consequence of rising food prices, which Inger Anderson talked about in her talk last night, a consequence is that as we speak, iron deficiency, zinc deficiency, vitamin A deficiency, and other mineral and vitamin deficiencies are getting worse in developing countries. Okay, let me present some data to back that statement up. This is to my mind, this is the basic story of the Green Revolution. That dashed line along the middle is a 100% increase between 1965 and the year 2000. You can see that cereal production more than doubled, more than 100% increase. The blue bar at the right is population increase. It just about doubled. But if you look at those green bars, that's pulses, but it's representative of all the non-staple foods that have the highest levels of minerals and vitamins. You had increases in production, but they did not keep pace with population growth. So what happened to food prices? The rice prices, the wheat prices, which grew those prices came down because production grew faster than population. But by the same token, the prices of vegetables, fruits, pulses, animal products, fish products, those prices went up because they did not keep pace with population and demand. So these are some data from rural Bangladesh, and the pie chart at the left shows how the diet is divided according to the energy contribution of 3 food groups. The food staples, the brown area, which is rice, the green, which is non-staple plant foods, and the red, which is fish and animal products. So the rice is cheap, so it provides 80% of the diet for the poor. Animal products, fish products are expensive. They provide only 3% of the energy of the poor. Now the pie chart at the right shows their food budgets, what they spend on those 3 food groups. So already the rural Bangladeshis, these were data that were collected in 1990s, they're already spending a quarter of their food budget on fish and animal products, 20% of their total income on fish and animal products, even though it's only providing 3% of calories. Rice is about half of the food budget, even though it's providing 80%. Okay, that was before the food price rises. That's how they were allocating their food budgets, which comprise 70 or 80% of their total income. Okay, now what I've done with these pie charts is show how these rectangles show how they divide their budget. This is the rectangle on the left comes from the previous figure. They are spending about 25% of their total budget on non-food items, 75% on food. The money they spend on food staples and the money they spend on all the other non-staples is about equal. Now what happens when food prices rise by 50%? How do the poor react to that? Well, they keep eating about the same amount of rice. They don't want to reduce their rice consumption because that's what keeps them from going hungry. So what they do is they have to spend a lot more of their budget on food staples to keep from going hungry, to keep eating the same amount of rice or wheat or whatever the food staple is in your country. And so that leaves a lot less money left over for the non-staple foods, for the green and the red areas on the right-hand triangle. And even then the prices are higher, so you have less money to spend and you have to pay a higher price. So what happens is your mineral and your vitamins, your intakes go down. So we've simulated this for example, for the Philippines, an average intakes for women on iron go from 7 milligrams of iron a day down to 5 milligrams of iron a day. Another simulation work shows that at 7 milligrams of iron a day, 70% of the women are iron deficient in terms of their intakes. And after the price rise, 95% of the women are iron deficient in terms of their iron intakes. So we know that micronutrient malnutrition is getting worse as food prices have been rising. So that makes biofortification, which is putting more minerals and vitamins into the staple foods through plant breeding, that makes the argument for biofortification, I think, even more compelling. So let me talk a little bit about our progress. I don't have time to go into a lot of the details. I just have a little bit of time to talk about the progress that we're making under HarvestPlus. So we're developing high iron and zinc pearl millets for distribution in India. We will release our first varieties in 2012. We're multiplying seed, and we will be doing delivery activities starting in 2012 in Maharashtra and Gujarat. We're developing high zinc rice for Bangladesh and India. Our first releases will be in Bangladesh in 2013, to be followed by India. We're developing high zinc wheat for India and Pakistan. We'll have our first releases of wheat in India in 2013. Now our products for Africa. We have high iron beans in Rwanda. Varieties have been submitted to the varietal release committees. We expect official release in 2012. We'll be doing delivery activities in Rwanda in 2012 and then on. Cassava, we have a high provitamin A cassava, yellow cassava. We expect official release this year. We're multiplying cassava stems, and we'll be into dissemination in 2012 and 2013 in Nigeria. Maize, we have high provitamin A maize. We have 5 varieties submitted to the varietal release committees. We expect official release in 2012. We're multiplying the seed, and we will have delivery activities in Zambia starting in 2012. Orange sweet potato has already been released in Uganda, Mozambique, several other countries. We've done pilot dissemination project there that's now been completed. There was a presentation on that in another parallel session yesterday. In that pilot dissemination of 24,000 households, we had 75% adoption rates. We were able to increase the intakes of provitamin A for women and for children. The light yellow lines were their baseline vitamin A intakes, and the dark orange is how much we were able to add to their vitamin A intake. So there were quite substantial increases in vitamin A intakes. So what are the advantages and what's the niche for biofortification? Well, first of all, it's cost effective, as was recognized by the Copenhagen Consensus, a group of economists that were asked to identify the 30 most productive investments that could be made in developing countries. 3 out of the top 5 were to fight micronutrient malnutrition, and biofortification was ranked 5th out of the top 30. We feel that an investment of $300 to $400 million over 15 years under HarvestPlus can have benefits of tens of millions of dollars, economic benefits of tens of millions of dollars. I don't have time to develop the arguments for that. Biofortification, as Lindsay emphasized, biofortification reaches the whole family, but it has the most benefit for women and for children because they're the ones whose requirements for micronutrients are the highest. It works best where women are farmers because it's women who are more receptive to the nutrition messages than are the men. It targets the rural poor. Biofortification starts in the rural areas, reaches into urban areas as the marketed surpluses get into the marketing system. So it starts at the opposite end as supplementation and fortification, and the complementary strategies meet in the middle. It's a sustainable strategy because the research costs are front-loaded. Obviously, biofortification links agriculture and nutrition, and HarvestPlus has a proven track record in bringing the agriculture and nutrition communities together over the past 8 years. And then finally, I want to emphasize that it's a technology that's now on the shelf. After many, many years of trying to get the strategy started, getting the investments, now doing the breeding for the past 7 years, it's now ready and waiting its technology on the shelf. And it will get better and better over time and have more impact as other varieties come out of the pipeline that are higher yielding and even higher nutrient values, and as those varieties diffuse within the food systems. So, thank you.